Hello students, welcome to Unit 4 Notes, Section 4.4. I did the warm-up, so feel free to pause at this time. You can ignore this diagram, it was incorrect, but we don't need the diagram to be able to complete each one of these statements, to which I did. So pause it right now, write them in, make sure you have the same thing for the warm-up. And the congruence criterion we've used up to this point is side, 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 angle, side, angle, angle, side, and the HL theorem. All right, so we're ready to start this next unit. So this next lesson. So this is called using congruent triangles, CPCTC. CPCTC. What does CPCTC stand for? It stands for corresponding parts of, which is ignored, but congruent triangles corresponding parts of congruent triangles are congruent. What it means is if you prove two triangles congruent by, let's say, side, angle, side, that means that all of the other sides and all of the angles are also congruent. So you have 6 congruent parts, 3 of them angles, and then 3 of them sides. And so all we're going to do is use the CPCTC. So with side, 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 angle, angle, and angle, side, as you know how to use the 3 parts of the triangles to show that the triangles are congruent. Once you have triangles congruent, you can make conclusions about their other parts because by definition, corresponding parts of congruent triangles are congruent. You can abbreviate it as CPCTC. State why the 2 triangles are congruent, give the congruent statement, then list all the other parts of the triangle that are congruent by CPCTC. So here's a great example. I'm going to say that KL is congruent to OM. I'm sticking with the correct order. I'm going to say angle L is congruent to angle M. And I'm going to say side LJ is congruent. Oh, give me a second. LJ is congruent to MN. So state why the 2 triangles are congruent. Well, the 2 triangles are congruent by the side, angle, side postulate, which is this information here. So we can say that triangle KLJ is congruent to triangle OMN. So we stated why the 2 triangles are congruent. Here was the information. Give the congruent statement. I gave the triangle congruent statement. Now I'm going to list the other parts of the triangles that are congruent. So here's the other parts. So what I do know is that angle K is congruent to angle O. Angle J is congruent to angle N. And side KJ is congruent to side ON in that order. So I'm going to put by CPCTC. By CPCTC, here's what I know. All right. Pretty simple, just expanding on what you already have been working on. All right. So we're already in the exercise notes. There wasn't too much to this lesson. It's pretty quick. What we have here is a problem with a sinkhole. So some distances are best measured indirectly. Probably don't want to walk over this sinkhole. Not a good idea. But what we can do, let's see, the sinkhole swallows house. The large sinkhole in this photo occurred suddenly in 1981 in Winter Park, Florida, following a severe drought. Increased water consumption lowers the water table. Sinkholes form when caverns in the underlying limestone dry up and collapse. So a geometry class indirectly measured the distance across the sinkhole. The distance they measured are shown below, as shown in the diagram. Explain how to use their measurements to find the distance across the sinkhole. So here's what I know. I know that 40 is congruent to 40. I know that 30 is congruent to 30, and I do know that vertical angles are congruent. So what I can say is, by side angle side, these two triangles are congruent. Therefore, by CPCTC, all corresponding sides and angles are congruent. And what does that mean? Well, that means that this side here has to be congruent to that side there, which is the width of the sinkhole. So the sinkhole measures 26.5 yards across. Okay, so that's the distance across. Crazy, huh? Alrighty. Yeah, I mean, and what that means is we also have like this angle here that's congruent to this angle here, and we have this angle here between the 40 and the 3 tick marks, between the 40 and the 3 tick marks there. So maybe just change that color. Let's do that one, and these. Let's change it to light blue is fine. Okay. And I'm just going between the 30 and the 26.5. So the 30 and 26.5 is this one right here. So that's why those have 2. All right. In the diagram, RXW is congruent to JXT, which statement is not necessarily true. Well, let's see, angle J and R, that one's true. Those are true. W and T, those appear to be true because they're the last ones. WX, so going this way, WX and JX. Ooh, that one doesn't look that good. And let's see, RW, and JT, those look good. So it looks like the one that doesn't work, is this one right here. WX and JX. Okay. Use the diagram below for exercises 23 and 24, which is true by CPCTC. Let's see. BAC, let me go around this. BAC, which is this angle, is congruent to DCA. We don't know that. Let's see. Well, let me gauge it from the statement here. So the statement is BAC, so BAC would be DAC, so we don't know that one. Okay, let's look at BC and DC. BC, DC, that one looks good. Okay, Let's take a look at ABE. ABE, which is that angle, and EDC is that one. I don't even see it in my statement, so I can't make that. And you know what? The AC bisecting BD, we don't know that either. That's not part of CPCTC. So the only one that works here is BC and DC. Which one is not true by CPCTC? Let's take a look. BE. Let me start with these angles. BCA. Let's take a look at that one. BCA and DCE. DCA. Let's see which one's not true. All right. Let me actually mark up this diagram. ABC is congruent to ADC. So that I'll put a tick mark there and here and there and there, and then I got angles. Let me try to color the angles a different color. Oops. Nope, what did I do? Angles are going to be purple. There we go. So that's what I do know. BE is congruent to DE. I don't know that yet. Let's see, BCA. BCA and BCA and DCE, that works. Those both have 3 tick marks. AB and AD, those work. Those have 1 tick mark. BAC and DAC, that works. What I don't know is this one necessarily. Okay, there's nothing to say that those vertical lines in both of them are equivalent. So we're not sure about that one. Okay. We're already at the practice. This video is not that long, so I might as well just do these practice ones real quick. So here we have angle A is congruent to angle C. We know that this is a right angle, so we're going to say ADO, and then we also have this part. Oh, sorry. We don't know A and C. It wants me to prove A and C. So we're not sure. What I do know is that triangle ADB is congruent to triangle CDB by the side angle side postulate. Therefore, angle A is congruent to angle C. All right, the next one. We have FH is the same thing. So we're going to say triangle FHE, that's the top one, is congruent to triangle HFG by angle side angle. Therefore, Therefore, HE has to HE has to be congruent to FG. All right. Triangle JLK is congruent to triangle NMP by angle side angle. Therefore, angle K is congruent to angle P. Oh, you know what? For all of these, I should say by CP, CTC. My apologies. That needs to go for all of these. Okay. So triangle TQS is congruent to triangle TQS RSQ by the angle side theorem. Therefore, angle QST is congruent to angle QST is SQR, angle SQR by CPCTC. All right, the last one we have triangle UVX is congruent to triangle WVX by side postulate. Therefore, angle U is congruent to angle W. By CPCTC. All right, 4 more. We're still going strong here. We got vertical angles right here. So, triangle YAZ is congruent to triangle BAC by the angle side angle postulate. Therefore, ZA is congruent to AC. ZA is congruent to AC. Let's just make sure the order's right. ZA, it should say CA. Should say CA. By CPCTC. Okay. Shared side. So triangle DEG is congruent to triangle FEG by side angle side postulate. Therefore, FG and DG are congruent. by CP CTC. Okay, we got vertical angles. So triangle HJK is congruent to triangle HDK MLK by the angle side theorem. Therefore, let's see, JK is congruent to, it should be LK, so JK is congruent to LK by CPCTC. We're going to make sure our order stays the same even though they're asking JK and KL. It really should be LK. And lastly, our last question of the day, we have side, side, side. They share that side, so I'm going to do R, triangle NRP, sorry, RNP is congruent to triangle PQR by side, side, side postulate. Therefore, N and Q are congruent. Angle N is congruent to angle Q by CPCTC. All right, that is it. We are done with those. So you actually have all of the notes and all of the practice for 4-4. All right, and then good luck on your IXL.